I welcome you to this session on permutations and combinations. This is the third session on questions based on digits. Let us look at another question based on digits. How many 4-digit odd numbers can be made from the digits 0 to 9 if repetition is allowed? And second question, if repetition is not allowed. Let us see how to solve this particular question. So once again, I draw a simple partition and we will list the analysis of the question on the right of this partition, and we will actually solve the question towards the left. So what are the conditions, what are the constraints given to us? Number one, so we require a 4-digit odd number. That is the first constraint. Then in the first case, repetition of digits is allowed. So let us once again try to solve this question. So these 4 squares represent the 4 places of digits. This is the units place, this is the tens place, here we have the hundreds place, and this is the thousandth place. And we have to place digits at each of these places in order to get a 4-digit number. Now, because we require an odd number, which digits can be placed at the units place? Obviously, the units place must have odd numbers or odd digits only. Which are the odd digits? 1, 3, 5, 7 and 9. There are only 5 digits which can be used in place of units number. So units place can be filled in 5 ways. Now because repetition of digits is allowed, all the digits are always available to us. So how many digits can fill up the thousandth place? The thousandth place can be filled with by any digit which is not 0. So there are 9 numbers which can fill the thousandth place. Once again, because repetition is allowed for hundreds and for tens place, you have all the available digits, each and every of the 10 digits. So if you multiply 9, 10, 10 and 5, you will get 4500. So with repetition, the number of numbers which are odd is equal to 4500. Now let us solve the same question for the case that repetition of digits is not allowed. Let us go ahead. So there you have these 4 blocks representing the 4 places of the number, and once again we are looking for an odd number, and therefore the units place can be filled in 5 ways: 1, 3, 5, 7, 9. Now because repetition of digits is not allowed in this particular question, therefore once we place a particular digit, we will not be able to use it once again. So once a unit place has been filled, we cannot use the same digits for any other position. So how many digits remain? Including 0, there still are 9 digits which can be placed in this box. And therefore, the number of choices could be 9. But 0 also is one of the remaining numbers. And we cannot have 0 at the thousandth place. So the total number of numbers that we can fill at the thousandth place is 8. What about the hundredths place? At the hundredths place, there are 10 digits possible, but because repetition of digits is not allowed and 2 digits have been used at the units place and at the thousandths place, the number of digits remaining which we can fill at the hundredths place is only 8. And similarly, the number of digits available for the tens place is 7. Because out of 10 digits, 3 have already been occupied. And once again, we have to fill the units, the tens, the hundreds and the thousandth place. Therefore, we will multiply here and our answer is 2240. Now let us solve another question. How many 4-digit even numbers can be made from the digits 0 to 9? The first part, repetition of digits, is allowed, and the second part, repetition of digits, is not allowed. How do you solve this question? Let us take a look at the first part first. So what are our constraints? Our constraints are, number 1, we are looking for a 4-digit number, and number 2, the number should be even. So let us once again start solving it. Let us say these 4 boxes represent the units, the tens, the hundreds, and the thousands place. Now, repetition of digits is allowed in the first case. Therefore, we start filling these digits. Now, how many digits can occupy the units place? Obviously, because we want these numbers to be even. So 0, 2, 4, 6 and 8. So we have 5 choices in which we can fill the units place. Now, how many choices are there for the thousandth place? At the thousandth place, repetition of digits is allowed. So we have all the 10 digits available, but we cannot fill the digit 0 here. And therefore, the number of choices will be 9. Similarly, how many choices are there for the 100th place? Repetition of digits is allowed, therefore we will have all the 10 digits available to us here. And even for the 10th place, we will have all the 10 digits available to us. So what will we get as our answer? Because we have to place all the 4 digits, therefore our answer will be 4500. Now, what will happen when repetition of digits is not allowed for the same question? Let us see that. Once again, we have these 4 boxes representing the units, the tens, the hundreds and the thousand place. And in this question, repetition of digits is not allowed. So again, we start by filling the units place. How many digits can occupy the units place? Obviously, the units place can be occupied once again by the same digits. We want an even number, so we can have only 5 digits. But now, because repetition of digits is not allowed, we will have to consider 5 different cases. Case number 1, when the units place has 0. Case number 2, when the units place has 2. Case number 3, case number 4, and case number 5. Case number 3, when the units place has 4. Case number 4, when the units place has 6. And case number 5, when the units place has 8. So if we know how many numbers can be formed when the units place is 0, when the units place is 2, 4, 6 and 8, then we can simply add up. So now when the units place is 0, how many digits can be placed at the thousandth place? We have 9 available digits, and any of these 9 digits can be placed at the thousandth place. So we have 9 digits which can be placed at the thousandth place. At the hundredth place, we have 8 digits, and at the tenth place, we have only 7 digits. So how many numbers in all? 9 into 8 into 7, which gives us 504. Now what happens when at the units place we have a 2? Now when we have a 2 at the units place, for the thousandth place we still have 9 digits, but one of those 9 digits is a 0, and therefore the number of digits available to fill the thousandth place will only be 8. And now once we have occupied the thousandth place and the units place has already been occupied by the digit 2, how many more digits are there for the hundreds place? Out of 10 digits, 2 digits are placed, so we will still have 8 digits here. And for the tens place, we will by the same logic have 7 digits. So what does that yield us? 448. Now what would happen when 4 would be at the units place? When 4 is at the units place, once again, for the thousandth place, we will have 8 digits available because 0 cannot be placed at the thousandth place. At the hundredth place, we will once again have 8 digits available, and at the tenth place, we will once again have 7 digits available. So, what is the total number of numbers possible in this way? 448. And by the same logic, we will get 448 numbers when at the units place we have 6, and 448 numbers when at the units place we will have 8. So what is the total number of numbers? The total number of numbers will be a sum of all these cases. Now why a sum? Because either case 1 or 2 or 3 or 4 or 5 can exist. And because we have an or in between them, we will add up these numbers. So we add up 504 plus 448 into 5, which gives us 2744 possible numbers. So with this we come to an end of this particular session of circles. If you wish to watch more videos or if you wish to know more about the topic, please log on to our website pfindia.com. If you want to ask a doubt, please write to us at studentservices@pfindia.com. And if you're watching this video on our website, please use the Ask a Doubt feature. Thank you very much.